This lesson we're going to be multiplying matrices. So multiplying is not quite as easy as adding and subtracting. You really, really want to make it easy and just multiply the elements together, but that is not the way it works, okay? And it's very particular on whether or not you can find each product. So before we do anything about that, let's talk about how you describe the size of a matrix. So it's always going to be row by column. Row by column. So for example, this is a 2 by 2. This is a 2 by 2. This one is a 3 by 2 and a 2 by 2. Coming down here, I'm just looking at a couple more. That's a 2 by 2, a 2 by 3, a 3 by 2, a 2 by 2, a 3 by 3, and a 3 by 2. So to be able to multiply matrices together, you have two sizes. So you have, like, let's say row the first one by the column of the first one, and you are multiplying that by the row of the second times the column of the second. So for you to be even able to multiply these two inner numbers right here, whatever the column of the first one and the row of the second one, have to be the same. Otherwise, you can't even do it. Okay? If those are not the same, it is impossible. And your answer is going to equal the size of the row of 1 times the column of 2. That's going to be the size. So for example, right here, this was a 2 by 2. This was a 2 by 2. These two matched, so that's good. And the size of this one is a 2 by 2, those outside two numbers. Okay, so let's just go through and look at the size of all these. This one is a 3 by 2. This one is a 2 by 2. Again, these two numbers match, so we're good to go. And our answer is going to be a 3 by 2, and you can tell that that's what happened. Okay, going ahead and looking through the rest of these, just, to clear that up from the beginning. This is a 2 by 2 times a 2 by 2. Again, those match, so your answer is going to be a 2 by 2. Okay, same thing here, so I'm not going to do those again. This one is a 2 by 2 times a 2 by 3. Again, these two match, so that's good to go. Your answer is going to be a 2 by 3, size-wise. Okay. This one is a 3 by 2 and a 2 by 2, so kind of same thing. Those match. Your answer on this one's a 3 by 2. Again, here's another 2 by 2. That one's good to go. This one is a 3 by 2 and a 1 by 3. Again, those numbers do not match. This one is not possible. Same thing here. Here's another 2 by 2 and 2 by 2, so we know that one's good to go. 3 by 3 and a 3 by 2. Those match. My answer is going to be a 3 by 2. Okay, so we're good to go there. Cool. So let's go through and look at the actual process behind multiplication. Okay, and let me tell you, whenever I do this, I keep drawing these circles over and over again to help me stay in line. Okay, first thing you're going to do is you're going to take this first row times the first column of the second one, and you multiply like the first two elements together, the second two. So here, and you can see they've done the work. -4 times 5 plus the 3 times -1. Whatever you get there, that stays in this first box. Then you do the same thing with the next column, the next row, and the first column. So again, 2 times 5, -2 times -1. You add those together and put them right here. So it's not what you think it would be. Okay, and it does take you a little time to get used to the process. That's why there are so many questions here. But it's also, mathematically not that difficult. You just have to keep track of what you're doing. So question number 1, and I'm not going to show any work. We're just going to talk about it. Well, I don't know, maybe. No, I don't want to show any work. I'm just going to do it. Okay, so first row times first column. Okay, that means 4 times 3. Plus 1 times 0. Well, 4 times 3 is 12. 1 times 0 is 0. So the first box is just 12. Okay. I'm going to do the same thing with this next row. So this row times this column gives me this box down here. So -2 times 3 plus 3 times 0. Well, negative 2 times 3 is a negative 6, plus 0 is still just negative 6. Okay. Now I do the same thing for my next column, but I use this one. So it's going to be the first row and the second column. So 4 times 0 plus 1 times 3. Well, 4 times 0 is 0, 1 times 3 is 3, so 3 goes right here. And then same thing with the last one. Last row and the last column. Negative 2 times 0 plus 3 times 3. Negative 2 times 0 is 0, plus 9 is a 9, and that's your answer. Okay, so it definitely takes some practice to get used to the method, and I still draw these circles even though I've been doing multiplication of matrices for a while. It just helps me keep organized and keep track of what I'm doing. Okay, so again, I'm not going to show any work on this one. This one's a little harder because there aren't as many zeros, but let's just see if we can do it all in our head. Again, I am not recommending you show work, but it's okay if you don't, as long as you keep track of all your negative signs and things like that. So negative 1 times 3 plus 0 times negative 1. Well, that's negative 3. That's 0, negative 3 plus 0, negative 3. And this row times this column. So again, 3 times 3, 7 times negative 1. 3 times 3 is 9. 7 times negative 1 is negative 7. 9 plus negative 7 is 2. Okay, same thing with my second column. So first row, second column, negative 1 times 2 plus 0 times 4, negative 2, 0, negative 2. This one times this one, 3 times 2 is 6, 7 times 4 is 28, 26 plus 28 is 34, and that's your answer. Okay, I'm going to skip down to one that's a little bit different than a 2 by 2. So like what if I did this one here? Okay, well, first of all, I know my answer is going to be a 2 by 3. So you might want to make it a little longer to start with. Sometimes I'll even draw little blank spaces in there to remind me how many elements I have. But you're still going to do this first row times the first column. Okay, negative 3 times 4 plus 1 times negative 3. Well, that is negative 12. That is negative 3. Negative 12 plus negative 3 is a negative 15. Okay. 5 times 4 is 20. Negative 2 times negative 3 is 6. 20 plus 6 is 26. Now do the same thing with the next column. So first row times the second column. Negative 3 times 0 plus 1 times 1. 0 plus 1 is 1. Same thing with this row and this column. 5 times 0, negative 2 times 1. 0 plus negative 2 is negative 2. And then my last column. So first row, last column. Negative 3 times negative 2 is 6. 1 times 1 is 1. 6 plus 1 is 7. Bottom row, last column. 5 times negative 2 is negative 10. Negative 2 times 1 is negative 2. That's going to be a negative 12. And that's your answer. Okay? What about just, I'm going to do the next one, and I'm going to do number 9, and then I'm going to be pretty close to calling it good. So the rest of this just still kind of works the same way. You just have a few more elements when we get down here to 9 to manage together. They still just all add, but I'll look at that one here in a second. Well, I'll just go ahead and do that. I'll come back and do 5. So my answer is going to be a 3 by 2. Okay. And I got a lot more elements to keep track of, so if you need to show a little work or something, that's fine. I'm going to do it all in my head, Hopefully I won't make any mistakes, but who knows. I do the 2 times the 2, plus the 0 times the 3, plus the negative 3 times the negative 2. So that's 4, that's 0, that's 6. So 4 plus 0 plus 6 is 10. Okay, I do the same thing with this row times this column. Okay, so 1 times 2 plus 4 times 3 plus negative 2 times negative 2. So that's 2 plus 12 plus 4. So 2 plus 12 plus 4 is 18. Okay, same thing with the next row. So last row, first column. Negative 1 times 2 3 times 3, 1 times negative 2. So that's negative 2, that's 9, that's negative 2. So negative 2 plus 9 plus negative 2 is 5. Okay, so that's my first column completed. Now I do my second column. So first row, second column. So 2 times negative 2 plus 0 times 1 plus negative 3 times 4. That's negative 4, that's 0, that's negative 12. So negative 4 plus 0 plus a negative 12 is a negative 16. Same thing, here's this row and this column. 1 times negative 2 plus 1 times 4 plus 4 times negative 2. That's negative 2, that's 4, that's negative 8. Negative 2 plus 4 plus negative 8 is a negative 6. Last one. Last row, last column. Negative 1 times negative 2, 3 times 1, 1 times 4. That's 2, that's 3, that's 4. 2 plus 3, 5 plus 4 is 9, and that's your answer. Okay. Same thing, like I said, I'm going to go ahead and do 5 for us just because our answer is again a 3 by 2. First row, first column. 3 times 1 plus negative 2 times 2. That's 3 and negative 4. That's a negative 1. Second row, first column. That's 0 times 1, 4 times 2. That's 0 and 8 is 8. Last row, first column. Negative 5 times 1, 1 times 2. That's negative 5 plus 2 is negative 3. Same thing with the second column. So negative 3 times 2 plus 2 times negative 1. That's 6 and negative 2 is 4. This row and this column, 0 times 2, 4 times 1. That's 0 plus 4, also 4. Last row and last column, negative 5 times 2, 1 times 1, that's negative 10, plus 1, negative 9, and that's your answer. Okay? Now on the back of these notes, there's a couple of different properties of matrices. So a couple of different things that, these are just your like associative and distribution and stuff like that. And some of it's true for matrices and some of it's not. Notice we usually have the commutative property. The commutative property is that if you do A times B, that's going to be the same thing as B times A. In matrices, this is not true. Okay, there is possibilities of having different sizes. That one of them's possible and one of them's not, but those are not going to be equal. I don't even know if there's maybe just very few examples of where they would even be equal. But that's not a property that holds for every situation. The ones that do are you do have associative. So if you have 3 matrices multiplied together, you can multiply 2 of them together and then multiply what you get by the third. Or you can multiply the back 2 together and then multiply the first one. As long as it stays in the same order, then it doesn't matter which ones you do first. Okay, the same thing with a scalar. You can either multiply them first and then multiply what you get by a scalar, or you can multiply the scalar through one of your 2 matrices and then multiply them together. Either way, you're going to get the same answer. And you can also distribute from either the right or the left with a matrice. Okay, so if you have these, you can either add them first and then distribute the C that way, or this way. And the reason they have to write it this way is because, again, the order matters. So the fact that, that this is the same as distributing this way, and this is the same as distributing this way. Notice that like here with the C in front, the C is still in front here. And notice with the A, B in front, the A or the B are in front of the C, because it matters which way you're distributing, like which one you multiply first, but you can still distribute just fine as long as you keep the things in the right order. So the way we're doing this down here is they give you a couple of matrices and they want you to figure out, can you do this? Like, is this possible? And if it is, what do you get? So like here, if you look here, we're trying to prove this right distributive property. Okay, notice how this is one side and this is the other one, and we're trying to prove that they end up being equal, so it is true. Okay. So there's a couple different, they have each one of them down here. We can distribute different things, and you're trying to make sure they're both equal. So what you would do is you would do one side and then do the other one to show that they're equal. I'm not going to do an example problem like that. You have a couple on your homeworks, but that's what you're supposed to do.